Steam ejectors use a motivating fluid and pressure to velocity energy conversion to create vacuum. Nozzles convert high-pressure steam to high-velocity steam in the mixing chamber to create a low-pressure region. As the steam and entrained air travels down the diffuser, kinetic energy is lost and pressure increases again. Steam ejectors handle high volumes of gases including wet, corrosive or particulate-laden vapors and operate in the rough or medium vacuum range with operating pressures to 3000 TOR. Multiple nozzle designs improve efficiency. Steam ejectors' low-maintenance design has no moving parts and can be mounted in any orientation. Multi-stage systems offer improved vacuum and may contain up to 6 ejector stages. The number of ejectors is determined by the level of vacuum required. Condensers are included to remove steam from the system and reduce load on the later stages. Shell and tube condensers, such as the one shown here, cool the steam down using arrays of cooling tubes. Condensate is drained from the system, allowing more steam to be added at the next ejector. Each system is a design, and multiple condensers can be used as well. Steam ejector systems provide the lowest capital cost among vacuum process pumps.